In 5.4, and that brings us example 10, we are told that you can solve problems about non-uniform bodies by finding or by using the center of mass. Non-uniform body is a rod that is, the mass is not distributed evenly, and the mass of an non-uniform rigid body can be modeled as acting at its center of mass. The previous examples that we have seen before, we have only dealt with uniform rods. Non-uniform rod is a rod whose mass is not evenly distributed, and the mass of non-uniform rod does not necessarily act at the midpoint of the rod. It acts at a point such that on the left of that point and on the right of that point, the masses of those two portions are equal, not necessarily at the midpoint. That is a point to note. So example 10, Sam and Tasneem is already in this question, are sitting on an ununiform plank AB of mass 25 kgs and length 4 meters. The plank is pivoted at M, and M happens to be the midpoint of AB, and the center of mass of AB is at C. You can see the plank or the rod is pivoted at point M, and the midpoint of the center of mass is at C. You can already clearly see that the mass of this rod does not necessarily act at the midpoint. It is acting at point C, which is now the center of mass, where AC is 1.8 meters. This is AC, 1.8 meters. Sam has a mass of 35 kg. Tasneem has a mass of 25 kg. This is a joke. Tasneem is not that light. 25 kg and sits at A. Tasneem is sitting at A and exacting a mass of 25 kg. And of course, the effect of Tasneem is, of course, 25 G newtons. And there is Sam with a mass of 35 kg, so exerting some force of 35 G newtons downwards. Where must Sam sit for the plank to be horizontal? Where must Sam sit for the plank to be horizontal? In other words, we are supposed to tell where Sam sit from either the fulcrum or from whatever point. This is point B. If we take moments about M, moments about M, it is very important to note that the reaction due to M is Rm, but of course the moment which is brought about by the reaction M is 0, because the fulcrum happens to be M, and therefore there is no distance. So we are going to take about, but before we can even go to the calculation, let us have all the details. What is the mass of the plank? What is the mass of the plank? It's supposed to be 25 kg. Plank AB and mass of 25 kg. So the force exerted by the plank is 25 G as well. Let's now see, of course, the anti-clockwise moment must balance with the total clockwise moment. And you can already see where C is and the fulcrum, our point of rotation, is. Basically, M is at the midpoint. If this is 1.8 and the whole rod is 4 meters, and this is 1.8, then this is 0.2 meters. Moment about 25, the mass of the rod, which is 25 G times 0.2. that is anti-clockwise. You can already talk about this is anti-clockwise. This is anti-clockwise moment. It's going that way. And the mass of Tasnim, the moment affected by Tasnim is also anti-clockwise, so plus 25g times 2. The distance from where Tasnim is to the midpoint is 2, which must be equals to the moment about m brought about by the mass of Sam. So 35g times, of course, x. In other words, 35gx. 35gx, because there is the distance of x meters between the point of rotation to where Sam is seated. 25g times 0.2 is 5g, plus 50g is equals to 35gx. Now, of course, you can already see that 35gx is equals to 55g. And divide by 35g, divide by 35g, you can already see that x is equals to 55 divided by 35. We can already see that x is equals to 1.57 meters to 2 decimal places. Now, x being 1.57 meters, you can give this answer in different ways. So you can say that Sam sits 1.5 meters from the point of rotation on the right, on the opposite side of Tasnim. You can also say that Sam sits 1.57 meters plus 2 meters, sits 2 plus 1.57 meters, which is 3.57 meters from Tasnim. So you can give this answer in whatever kind of, in many formats, but of course, the moment you have found your x, then you can give your answer depending on what you had taken your x originally to be. But those answers are all of them correct. All right?